So we're finishing expressions containing several radical terms, which is 10.5. And let's see. We will talk about rationalizing binomial denominator and simplifying a little bit more expressions. So, and then we're finishing, we finished 10.5, and we will start 10.6 today. All right. So let's share the page, share desktop. All right. Okay, so let's see. Not 115. Sorry. That's 125. 10.5, right? Where is it? How do I find it? Search 10.5. Where is my 10.5? Yeah. Where is my 10.5? Hold on. And did you see it? Did you see it? Where? Wait. Oh, okay. Thank you. Okay. How did I put it under 10.1? I don't understand. That's why the organization of these notes. Or maybe I'm not knowledgeable. That's why. Okay. So anyway, remember this is specific special product. Yeah. So see, rationalizing binomial denominators. Did I say I was going to give you a quiz today? Yes? No? I said Monday? Are you sure? Okay. Rationalizing binomial denominator. Okay. So anyway, what do I mean by that? We don't want a radical on the bottom. So if I have, for example, 3 divided by 4 minus square root of 7, how do I get rid of the radical on the bottom? That's my question. Multiply by 4 plus square root of 7, 4 plus square root of 7. So it has to be the opposite sign. If this is minus, then you have to multiply it with the plus. Yeah? Good. And then you have to continue. What about if you have 1 plus square root of 2 divided by 3 plus square root of 5. So what do I do here? I multiply by the negative 3 minus square root of 5 over 3 minus square root of 5. Okay, so you think this is doable? Let's do it. Yeah. So this is binomial, so let me just put parentheses. So because they're binomial, yeah. Okay, so when I multiply, what happens here? Which one cancel? The radicals, only the first and the last. So what is the first? 4 times 4, that is 16, minus square root of 7 times square root of 7, that is minus 7? Yes. So what is 16 minus 7? 9. Yes. Okay. And what do we have on top? 12 plus 3 square root of 7. Okay. So 12 plus 3 square root of 7 divided by 9. Can we reduce? How? Divide by 3. Yes, these are all divisible by 3, right? So I could divide the 12 by 3, the 3 by 3, and the 9 by 3. Yeah. So what is this equal to? 12 divided by 3 is 4 plus square root of 7 over 3. Okay. Now, can you leave it like this, the answer? Yes, because this doesn't have an I. Yeah? So, oh, we haven't talked about I, did we? No, okay, so later. Yeah? So if you have a radical, you could put it like this, but if you have an I, the complex conjugates or complex number, you have to write it as A plus BI. So this is divided by 3, divided by 3, divided by 3. What were you going to ask me? Why? To get rid of the radical. Yes. So if you have two terms and you have to get rid of the radicals are on the middle terms. Okay, can you guys move? Karen, can you move here, please? Okay, thank you. Who else is busy? I'm going to move you guys. Yeah. So, so because of the special product, you only have first and last. So when you do the first or the last, then the radicals will cancel. Yeah, that's right. Okay, great. Good questions. Yeah. Now, number 2. Oh, can you try it, actually? Okay, I think you could try it. And then number 3. So square root of 7 plus square root of 5 divided by square root of 5 plus square root of 2. So here we only have square roots. We will not have cube roots. For a binomial denominator, we only have square root. We do not have cube root. 5 square root of 3 minus square root of 11 divided by 2 square root of 3 minus 5 square root. Okay, I'm going to go around. I need you guys to try these, please. Yeah. Okay, I haven't called the attendance for the longest time, so let me see. So Nestor dropped. Is Daniel here? Oh yeah, you're there. Okay, thank you. So only Joe Arachiga is absent. Yeah, everybody else is here. Okay, let me see. So how many more questions? Okay. What happens to number 2? Okay, so first, and then how did you get to no, you have to before it. So this is binomial, this is binomial. First is 3, other is later is 0, 5, last is this is binomial. Yeah. So, are you okay here? Okay. Are you good? Did you follow? Binomial. gotta do the first. Okay. First is 3 times 3. Last is square root of 5 times negative square root of 5. So this is minus 9 minus 5. Okay. And then on top, binomial. So this is a binomial. This is a binomial. So it has to be first. Okay. So first one and last. So Victor, are you okay? Okay. Okay. So number 2. All right. You guys, sorry. Okay. So for number 2, look at these. This is a binomial, isn't it? So you have to use FOIL. So on the top, you have to use FOIL. So what is first? 3. What is outside? Outer? Minus square root of 5. Inner? Plus 3 square root of 2. And last? Okay. So that's what you need to do, because those are binomial. Yeah. And then on the bottom, so remember, this is a special product, so we could use the shortcut. Yeah. What do you know? The outer and the inner will cancel, so you only have the first and the last. What is the first? 3 times 3, which is 9. What is the last? Square root of 5 times negative square root of 5. That is, yes. And then you continue. Yeah. I don't think you could simplify the top anymore. So you just leave it the way it is, divided by 4. Yeah, they're different radicals, you see. You can't really add those or subtract those, so you practically, divided by 10. How did I get 10? 9 minus 5 is 4. Make sense? So there's nothing you could do on top. Yeah. So remember, the top is binomial, also number 3 and also number 4. Yes. Because they're all divisible by 3. Yeah, so look at that. 12 is divisible by 3. 3 square root of 7 is divisible by 3. 9 is divisible by 3. Like this, number 4, look at these. There's nothing divisible by 2 or by 4. So you can't really.
You can divide 3 and 9 and it's still like 9 minus 5.
Say it again, say it again.
You can divide like 3 minus by 9.
The 3 by the 9. Is it for number 1 or number 2?
So number 2, when it's like 9 minus 5.
9 minus 5. No, you can't.
You can?
No, that's if no, you can't. Okay, let me do this. Suppose I have 3 plus 1 divided by 3. Can you divide these?
No.
No, right? Why not? What is 3 plus 1 divided by 3? 4 over 3. Yes. So you can't divide those and then you say, oh, I'm left with 1. So if you have addition or subtraction here, you can. However, if you have 3 times 2 times 7 times 8 divided by 3, can you divide this 3? Yes. So if these are products, yes, you can. But if this is addition or subtraction, there is no way you could do it. Yeah? Okay. So they, remember, subtraction or addition, you cannot cancel. So this is wrong. You cannot. Okay. But if you have multiplication, so these are factors, yes, you can. All right. Okay, you made a mistake again. So this is plus. What is the quantity? If I multiply by plus, and that's going to be my second product. So this one has to be okay. So if this is plus, this one has to be okay. So the signs, they have to be opposite. Those two should be different. So I can say, That's not very practical, right? I mean, it's better if we use mentor and later. Okay. Okay. So, do you have somebody in the answer before? Thank you. Thank you. Right, thank you. So I would have to ask him to get an answer. Because I will not remember. I will forget. Remember. Thank you. Thank you for remembering. Okay, so let's discuss it. Oh, it's actually cold today, isn't it? Is it getting cooler? Oh, okay. Oh, okay, good. Yes, it is. 75 is actually perfect, right? What do you think? What temperature do you guys like? Oh gosh, that's too cold. Oh, you guys have to move to East Coast. No, that's too cold. Yeah. Well, 70s are good for me, so I don't know. All right, so and then 90s, 80s are beach days, right? Yeah. Okay, so let's start with number 3. What am I supposed to multiply this with? Square root of 5 minus square root of 2. Yes. Okay. Good. So if this is plus, when you multiply, it has to be the opposite, minus. Now, this is a binomial. Let's put parentheses around the binomial. Okay, so what do we have on the bottom? Okay, so it's just the first and the last. So the first is 5, square root of 5 times square root of 5, that is 5. And the last is square root of 2 times negative square root of 2, that is minus 2. Yes, finish. Now, what do you have on top? FOIL, right? First, square root of 35. Outside, minus square root of 14. Inner, plus 5. Last? Okay. All right. And then that's it. Can we simplify the top? No, so just copy it. And then 5 minus 3 is 3. Finish. Easy? Okay, last one. So what do I multiply it with? 2 square root of 3 plus or minus? Plus. So this is minus, so you need to multiply by the opposite signs. Plus 5 square root of 2. So this is binomial. All right. So this is equal to, let's do the denominator first. First, what is the first? 4 times 3. If you already know it's 12, then you could just write 12. Okay? I'm not making you write 4 times 3. Minus, so 5 times 5, 25. Square root of 2 times square root of 2 is 2. All right. So what is it? 12 minus 50? What is 12 minus 50? Negative 38? Okay. So now let's multiply the top. So 5 square root of 3 times 2 square root of 3. 10 times 3. Or 10 times square root of 9. Right? Okay. But we also know square root of 3 times square root of 3 is 3. Outer. Plus 25 times square root of 6. Inner. Minus 2 square root of 33. Less. Minus 5 square root of 22. All right. So just can I simplify anything here? Well, 10 times 3, I have to write 30 plus 25 square root of 6 minus 2 square root of 33 minus 5 square root of 22. Everything divided by negative 38. So this is the only place where you can put the negative down. So just leave the negative down. Yeah. Don't worry about it. Just leave it down. I don't know why in Math Excel you should leave it down also. So even if negative, usually you can't leave it down, but no, just put it down there. Yeah. The one time. Usually you can't, right? Usually you put it on top or where? In the middle. Yeah. Okay. Is this easy for you? Because I'm done if it's easy. Yeah. I will simplify. I will move on to the next simplifying, the next part. Are we okay so far? No, this is I mean, one of the most challenging. You have all the coefficients. It's not challenging, right? It's so. Okay. Basically, you have to have negative and positive. That's it. So if you have a positive, then you have to have a negative when you multiply. And also if the denominator is negative. Oh yeah, if the denominator is negative, just leave it there. Yeah, so you don't have to do more stuff, right? Yeah. Okay, good. Now D is simplifying roots with different index. So it looks like this. Okay. And we have never done it before. Simplifying roots with simplifying radicals. I want to say simplifying radicals with different indices. Indices is the plural of index. All right. So, for example, how could we multiply cube root of x to the x squared multiplied by 6 root of x to the 5th? And then you said, oh, usually we cannot, right? Okay. But then this one we could do it. Why? Because because this is both I have x. Yeah. If I have cube root of 2 times 5th root of 3, what can I do? Nothing. Okay. However, this is x and this is x. We could do something about it. So here, nothing to do. We're done. That's your answer. That's it. Nothing to do. You cannot simplify unless you use calculator to approximate. Yeah. Now, what do you think we will do? We will write it as rational exponent. Do you remember that? What is cube root of x squared? X to the 2/3. Okay. Good. How about x to the 6? Okay. Good. And then what do you do to the exponent? You add? Yes. 2/3 plus 5 over 6. Okay. Now, this is pre-algebra. When I'm adding 2/3 plus 5 over 6, that is pre-algebra. How do you add 2/3 plus 5 over 6? LCD? Okay. Which is 6. And then what do you do? This is 3, this is 6, so this is, yeah, multiply by 2, so 4 over 6 and 5 over 6. So this is x to the 9 over 6. Can we reduce 9 over 6? 3 over 2? Yes. All right. So now this starts with radical, so I'm going to leave it back as radical. So how do you write x raised to the 3 over 2 in terms of radical? Wait, which one is the index here? Square root of x cubed. And then I could factor out this is more than 1, so actually I have x outside. X squared times x. Yeah. So if this is greater than 1, for sure you have to take out the x, or x squared, or x cubed, depending on it. So can I factor out a perfect square from x cubed? What is it? What is it? X squared times, okay. So now I have to take out the x squared, it becomes x square root of x. Finish. Yeah. So which one is the part which is pre-algebra? Yeah. So if you're adding the fractions and you don't know how to add fractions, it's not that you cannot do intermediate algebra. It was pre-algebra, right? You could do intermediate algebra. It's just the pre-algebra needs to be better. Yeah. Okay. Can you guys try this? So 4th root of a cubed times cube root of a squared. And then number 3, 5th root of a cubed b. So give space because this is pretty long, you see. Multiply by square root of ab. So can we do this first? Can you try it first? I think you could try. So this is from 10.1, or no, 10.2, right? Rational exponent. So actually math is like building. So you have a foundation, and then the next day you learn something on top of it, and the next day you learn something on top of it. So if you don't learn the foundation, then of course, how do you build the one on top of it? Make sense? So that's why if you want to be successful in any math class, you have to do your homework every day. Like every day. Yeah. Do you do your homework every day? Okay, well, try your best. Yeah, sometimes you don't have time, but most days you should be able to do that, right? Yeah. Because otherwise, well, whatever we learn the next day, we need it the next day, and the following day we need it too, and then we haven't done our homework and we don't remember how. Yeah. Okay, let me give you 5 minutes. Yeah, I gave her phone number also. I don't know where she is. Yeah, you can on that one. So it's 17 and 12? Yeah. So it's the 12 and 5? Yeah. Yeah, this is 12. Yeah. 12 through. Then for the AQB, then you're going to separate it. A raised to the 3 over 5. B raised to the 1 over 5.
Oh,
yeah.
Oh, it's 2 different ones?
Yeah.
Okay.
Yeah. So for number 3, you're going to separate it. So the A, you're going to write A to the 3 over 5, B to the 1 over 5, correct? Okay. How about 2? 2 is okay? What's the answer? Oh, you forgot the 2. Yeah. Okay, so 9 plus 8 is 30. Oh, you forgot everything. Yeah. So this is all multiplied, right? So you multiply it. This is the condition. 3 over 5 plus 1 over 6. Multiplied by 3. No. So you have 8 again. I 8 again. So this one is correct. No, you're using this property. You keep the base. Oh no. Okay, yes. This one is also
Wow.
Oh, you're missing the song. Oh, okay. Okay. Okay, so let's research it. Okay, so number 2. All right, so let's start now. So how do you write this? A raised to the 3 over 4 times a raised to the 2 over 3. Okay, now then you use this a to the m, right to the a to the n is equal to a to the m plus n. Okay, so that's what we're going to use. So this is a to the, what do I do here? You add the exponent? Okay, then how do we add 3/4 and 2/3? So what's the LCD? 12. So a 12 plus 12. So again, this is not intermediate algebra, right? This part is pre-algebra. Yeah. So multiply by 3, multiply by 3. So 9 over 12. How about this? 4 times 4. So this is 8 over 12. Now, if you need help with adding fractions, come to my office hours or come to SIs. You need to be able to add fractions. Yeah, well, this is already Math 125. All right? And it's fine. So 17 over 12. Okay? Now, what do I do? Rewrite it as 12th root of a to the 17th. Yes. Now, you have to break it up because this is bigger than 1. So, what is this? A to the 12, a to the 5th. Okay. Now, what is 12th root of a to the 12th? A 12th root of a to the 5th. Yeah. So, remember to write these down, the 12th root. Yeah, I saw some of you forgot. Yeah. So, it's the 12th root. Doable? Okay. Okay, good. So let's continue. Number 3. Okay, so I'm going to split up my a and the b. So this is a raised to the 3 over 5. B raised to the 1 over 5. Good. So that's this part. So I'm splitting up the a and the b. How about here? A raised to the 1 over 2, B raised to the, okay. Did you figure out?
Yeah, they just called me, they didn't send me an email, and I called her, and she didn't respond.
Oh, okay.
I have the picture of my timesheet.
Okay, so you're good.
Yeah.
Okay. I don't know. She called me, so I don't know. Today. So that's why. So now let's combine the A and the A. So what do I do here? A raised to the 3 over 5 plus 1/2. So you're multiplying this, right? And you also multiply the B, 1 over 5 plus 1 over 2. Okay. So let's do the algebra of adding fractions here. What's the LCD? So 5 and 2, the LCD is 10. All right. So now this is 5, this is 10. What do you do to 5? Top and bottom. So this is 6 over 10. And then this is 2, this is 5. What do you do? About 10, you multiply by 5. So this is 5 over 10. Are we okay so far? Okay. Now let's do the B. Oh, same also 10, right? All right. So now this is 5, so you have to multiply by 2, and this is 2, so you have to multiply by 5. Okay, good. So this is A to the 11 over 10, B to the 7 over 10. Yes. All right. So now we put it back to 10th root of A to the 11, B to the 7. Yes. Which one can we break down? A to the 10 times A. How about B to the 7? No, 7, this is smaller than 10. So take out A to the 10th. A, 10th root of A, B. Okay. Are we okay so far? Yes? Okay. So next one. 3 more problems, and then we're done with this section. Yeah. It's division, but division is almost the same, right? You just what? Subtract. Yes. So number 4. What about if I have cube root of A squared divided by 4th root of A? And then number 5, we have square root of AB cubed divided by square root of, fifth root of, that's fifth root, not square root, A squared B cubed. And then number 6, what about if I have 3x minus 1 cubed. This is 4th root divided by 5th root of 3x minus 1 cube also? Okay. So do you want me to do one of them, or you guys are okay? Okay. So basically you're subtracting, right? 2/3 minus 1/4. Yeah? Okay. So what homework do you tomorrow? 10.5 only? 10.4 was due on Sunday already? Oh, okay. Okay. I think the other Math 125 is a little bit more advanced, more already does this section, right? They probably finished chapter 10. Yeah, they're ahead. Do you guys have any other? Oh, they're behind? You mean what sections are they on? Oh, okay. But it's a 2-day class maybe, right?
Yes. No,
Oh, okay. Why are they behind? Do they discuss more on chapter 8? Or?
I think I'm traveling to matrices.
Oh, okay, yeah. Matrices, okay. Are you guys almost done? With one? Should we discuss it now? Not yet? Okay.
So you're going to split it up again, right? A raised to the half, B raised to the 5/2, right? So what about you? So you're subtracting, and this is extension. For 45. You edit it? Small? Oh, what is it? Does it make money to it? Yeah.
Oh, by the way, let me show you. Okay. If you ever miss a class and you want to view the recording right away, it's available 20 minutes after. But not in the YouTube form in 3C Media Solutions. That's like a day later. But here is how to find it. Did I or didn't I? So what you do is cccconfer.org. I show you? Okay. Then where do I go? Scroll down and then watch recording. And then you have to put my name here, my first name, and Siswanto, and then it's going to say search. Just say search. And you see the one that I have today, this is today, the 11th, right? It's already available here. So it usually takes 20-30 minutes. But the one in 3C Media Solutions, no, not until tonight. They're not available till tonight, sometimes tomorrow. So if you want to watch right away, but the thing is I don't label this. I don't say, oh, this is section 9.5, this is section 2.1. So you need to know which days you missed. And then just watch that recording. That's the only thing. Yeah? You guys get it? So if you need it right away, just say you're absent yesterday and you want to watch. Sometimes the videos are not available, but 20 minutes after, so now we're done at 10:40. At 12, it's going to be done. No, everything. It's just not it's not as big as, it's not a YouTube file. So yeah, I could show you later after I close the recording, because otherwise it's going to mess up the recording right now. Because I'm recording now, right? Yeah. Okay. So yeah, we have 10 more minutes. So okay, so let's see. What about this? This is a raised to the 2 over 3 divided by a raised to the 1 over 4. And then what would you do here? Subtract, right? So a to the 2/3 minus 1 over 4. Okay, good. So now, what's the LCD? 12. All right. Good. And then the LCD is 12. So this is multiplied by 4. So this is 8 over 12. What about this? 3. So this is 3 over 12. Yes. So what is 8 minus 3? 5 over 12. Can we write it as root? 12 root of a to the 5th. Yeah, you can't do anything. This is smaller than 12. Yeah, you can't do anything. Yeah, that's right. Doable? Okay. Now the next one is a raised to the 1/2, b raised to the 3 over 2, divided by a to the 2 over 5, b to the 3 over 5. Alright, so what do you do with the a? You subtract the a, 1/2 minus 2 over 5. b multiplied by b raised to the 3 over 2 minus 3 over 5. Yes. Good. Then what? LCD, which is 10. So this is 2, this is 10. What do you do? Multiply by 5. So I need to multiply by 5. And then this is 5, this is 10. Multiply by 4. So this is a to the 1/10, right? Okay, now the b, let's work on the b. LCD is 10 also. So this is 2 times 5? 15. This is 5 times 2? 6. Okay. So a raised to the 1/10 multiplied by b raised to the 9 over 10. Okay. Then can I use the root? 10th root of a to the first power. We don't write it. B to the 9. Yes. That's it. Yes. Because they're less than 10. So you can't take it out. Yes, Johnny? No, because a and b here are the same root. You see? Because the a is 1 over 2, 3 over 2. Right? Yeah. Yeah, that's right. Usually not. Unless you have another thing here. Right? But no, they should be the same. Now, number 6. What would you do here? So this is 3x minus 1 raised to the 3 over 4 divided by 3x minus 1 raised to the 3 over 5. Okay. So this is 3x minus 1 raised to the 3 over 4 minus 3 over 5. Okay. Same thing. What is the LCD? 20? Yeah, so 20. 20. Okay. So this is 4 times 5, 3 times 5. So this is 15. What about these? 5 times 4. So the 3 also multiplied by 4. So 12. Yeah. So now this is equal to 3x minus 1 raised to the 3 over 20. Okay. Then 20th root of Okay. Raise. Yes. Good. Doable? Easy? Okay. So I'm done with what is the section? 10.5. Should we start 10.6 now? 5 minutes. Maybe let's just have a quiz. No? On this, yes. And then the binomial, 5 minutes. No, maybe let's do more problems. Yeah. You want quiz? One problem quiz? One problem like this? Oh, okay. That's it? You don't want a quiz? You don't think this is easy? Okay, so let's do one problem on this, okay? Okay, you guys always win anyway, right? Alright, so let's do it. So tomorrow we'll start 10.6, yeah? Alright. Oh, this is 10.6. Okay. What about this? Okay. So let's just do something like this. This is different. So suppose let f of x is equal to x squared, and then you have to find, this is easy also, f of square root of 2 plus square root of 10. All right. Okay, so how do we do it? Yeah, basically what does your function do? What does your function tell you to do? Square it. So this is just square root of 2 plus square root of 10 square. You're right. Which is square root of 2 plus, this is binomial, so you can just say 2 plus 10 because it has middle terms. Yeah. All right. Do we have to do FOIL here? Yes. So first, what is your first? 2. Outer. You multiply. 20. Yes. Inner. And last. Okay. So this is what? 12 plus 2 square root of 20. Can I simplify square root of 20? Yes, no? Yes, it is 4 and 5. Okay, good. So this is 12 plus. So the square root of 4 gets out, it becomes 2. So but you have a 2 in the front already. So 4 square root of, okay, finish. Yeah. Now, what about this? This is also like challenge for you. What about if you have 4th root of a squared b multiplied by cube root of a squared b minus 5th root of a squared b. This is 5th root. This is 5. This is number 5. A squared b squared. Oh, I've never seen it before. Okay, yeah, this is challenge. What do you think? But you can't. So you're going to write it like this, right? So 4th root of a squared b multiplied by cube root of a squared b. Is it? This is too long. Okay. And then what? Minus 4th root of a squared b times 5th root of a squared b squared. Then we know how to do each one of these, don't we? Okay, so what is this? A to the 2 over 4 or 1/2. Let's just put it 2 over 4. b to the 1/4. And this is a to the 2/3, b to the 1/3. Yeah. Do we know what to do with this? Of course, right? We just did. So what do you do to the exponent? You add them 2/4 plus 2/3. How about b? 1/4 plus 1/3. So let me do the left first, and then we will do the right next time. Then what? LCD, which is 12. Same for both A and B, right? So this is 4, but I need 12. Multiply by 3. Top and bottom. This is 3, this is 12. Multiply by 4. So 2 times 4 is 8. Are we okay so far? And then B, raised to the 1/4, this is 12. So multiply by 3. 3. And this is multiplied by 4. So this is A raised to the 14/12. Oh, why am I using that? Sorry. B to the, okay. Alright, so this part's done. We're actually almost done. 12th root of A to the 14, B to the 7. But what about this one? Right? A, 12th root of A squared. Okay. That's done with that. Then you have to do it for the other part. Does that make sense? So it's the same thing basically. Yeah. So do you want me to finish this or no? You think you can finish it? Yeah. So tell me tomorrow, tell me the answer here. Okay? Alright. So yeah. So you can go home. So tell me the answer tomorrow. Yeah. It's not hard. Yeah. Not hard at all. A little long, but you'll get used to it. Yeah. Okay, guys. Thank you for coming. We'll see you tomorrow. So homework due tomorrow is 10.5. Yeah. Try to finish it. Don't wait. Yeah. Okay. All right. So stop this, and then we save. So we're done with 10.5. Tomorrow we will start 10.6. Yeah.